Today in geometry, we are looking at section 9.4, rotations. So as we always start out with our notes, we need to start out with what is the definition of the rotation. So a rotation is a transformation that rotates each point in the preimage about a point P, which is called the center of rotation, at an angle measure of x degrees called the angle of rotation. And this is how we distinguish that it's a rotation I want. Lowercase r means rotation. Remember the other day, capital R is reflection. So lowercase r is rotation. The first thing in our parentheses tells us the degree measure that we're rotating. And then the second thing tells us what we are rotating about. A rotation has these properties. So if we look at this picture over here, I have triangle ABC. If I am rotating about the point P, so the image of P is P prime. For pre-image point A, the length between A and P and A prime and P is the same. And the measure of the angle A prime is X. So this is the angle that we are rotating about. This is my A, this is my A prime, P and P prime are the same. A rotation is a rigid motion, so length and angle measure are preserved. So we're not changing the length of anything, we're not changing the angles of anything. And then it says, note, a rotation is counterclockwise for a positive angle measure. So if we go counterclockwise, we have positive angles. Therefore, if we go negative angles, so if we have a negative angle, we are looking at clockwise rotation. So that's the difference between counterclockwise and clockwise notation. Rules can be used to rotate a figure 90 degrees, 180 degrees, and 270 degrees about the origin, O, in the coordinate plane. And again, all of these rules are ones that we discovered last week when we did the activity with the patty paper and the mirror. So the very first one, rotate 90 degrees about the origin, x comma y. So if I have the point 1 comma 2 and I'm rotating 90 degrees, and again, I am rotating counterclockwise. 90 degrees is one quadrant, so I'm ending up over here in this quadrant. It becomes negative y comma x. So this would become the point negative 2, 1. So the point negative 2, 1 would be right here. So negative 2, 1 is my point. So this is a 90-degree rotation. The next one, if I'm rotating 180 degrees about the origin, the point x comma y becomes negative x comma negative y. Remember, 180 degrees is two quadrants. So this would become the point negative 1, negative 2. So negative 1, negative 2 would be down here. And so this is 180 degrees, but it's a straight line, so we can see that it's 180 degrees. A rotation of 270 degrees about the origin, x comma y, becomes y comma negative x. So this would become 2, negative 1. So the point right here. And this would be my 270-degree rotation. I do not have on here the 360 degrees, but remember that 360 degrees just takes us right back to where we started. And then again, if I was doing negative, so negative, I would have just gone the opposite direction. So negative 90 would have put me in this quadrant. 180 and negative 180 are going to put me in the exact same spot. Negative 270 would have put me in this quadrant over here had I done negative 270 on that. So just remember that the negative tells you which direction you're rotating. All right, so now we're going to look at drawing rotations in the coordinate plane. This is what is the rotation of 90 degrees about the origin of ABCD. So here's my ABCD. So first, let's go ahead and write down what are our ordered pair, our coordinates of A, B, C, and D. So if I look at that picture over there, A is at 3 comma 5, B is at 1, 7, C is at negative 2, 4, and D is at 2, negative 1. They want a rotation of 90 degrees, so that means I'm going to do negative y comma x. And again, these are just rules that we are going to memorize. And so A prime, so negative y becomes negative 5 comma 3. B prime becomes negative 7, 1. C prime becomes -4, -2, and D prime becomes 1, 2. So then it says draw A prime, B prime, C prime, D prime on the coordinate plane. So now we're going to plot those points. So if I plot -5, 3, there's my A prime, -7, 1, A prime, -4, -2, C prime, and 1, 2 is D prime. And then if I connect those, so that's what it looks like after it had been rotated 90 degrees. Again, that is counterclockwise. And so now we'll practice doing that without a graph. And so the vertices of triangle XYZ are at x -4, 7, y 0, 8, z 2, -1. What are the vertices of a rotation of 180 degrees about the origin of triangle XYZ? Remember that our rule for 180 degrees tells me it's a -x, -y. So I just changed the sign of both of them. And so x prime is going to be at 4, -7. Y prime is going to be at 0, -8. And z prime is going to be at -2, +1. Next one, what are the vertices of the rotation of 270 degrees about the origin of triangle XYZ? So our rule for 270 degrees is y, -x. So x prime, again, I go back to where I started. I started at -4, 7, so that becomes 7, +4. Y prime becomes 8, 0. Z prime becomes -1, -2. And again, we're just going to memorize those rules. Okay, so now we're going to look at using rotations. So we talked about, it says the first drummer in a drum line is at the 20-yard line, and the sixth drummer is at the 35-yard line. Okay, so I'm going to call my I'm going to call my first drummer. And I'm going to call B my sixth drummer. So I can label them on here. So my first drummer, they tell me, is at the 20-yard line. So my first drummer, I'll just put him right here, and I'm call them A. And it said that the sixth drummer is at the 35-yard line. So 35-yard line across, I'm calling him B. The drum line rotates counterclockwise 180 degrees about the sixth drummer. Okay, so I'm rotating about my sixth drummer 180 degrees. So basically a straight line. Okay? So how far is it between A and B? So from 35 to 20 is 15. So then I have to add 15. So 35 plus 15 puts me at 50. So right out here on the 50-yard line is going to be my A prime. So this was my 180 degree rotation. Okay? So it says the drum line rotates counterclockwise 180 about the sixth drummer. We did that. Then rotates 135 degrees clockwise about the first drummer. So now I need 135 degree rotation. So if I look at, I can see 135 is going to be about right there. So I know there's my 135 degree angle. And now I need to find out what the distance is. Remember that my distance, they're all the same distances. So I'm just going to measure. So not quite 2. Right here is going to be my B prime. And so this was my 135 degree rotation. And so we just did all those steps. So number one, we drew the pre-image. I rotated the drum line 180 degrees about the sixth drum line. I rotated the sixth drum line 135 degrees about the image of the first. The drum line was first transformed by the rule of rotate 180 degrees about my first, about my sixth drummer, which I called B. Then I rotated clockwise. So it was a negative 135 degrees about my first drumline that had moved, so A prime. I can write that as a composition. So we always do the second one first, negative 135 comma A prime. This little open circle means a composition of a rotation of 180 degrees comma B. So anytime you see something written like this, we always start on the inside, so this one gets done first. So first I rotated 180 degrees about B, then I rotated negative 135 degrees about A prime. So then it says, okay, suppose the drumline instead turns counterclockwise about the image of the first. Okay, so now instead we're going to turn counterclockwise. How many degrees must it rotate so that the sixth drummer ends up in the same position? So I want to know, so now instead of going this direction, I want to go this direction, but I still want to end up here. Remember that all the way around a circle is 360 degrees. So I already went 135 degrees of it. So if I take 360 minus 135, that tells me what's left. So 225 degrees. So a 225 degree counterclockwise, so counterclockwise rotation is the same thing as equal to 135 degree clockwise rotation. Okay. And then it says, can the composition of rotations, this one that we just did right here, be described as a rotation of 45 degrees about A, since 180 minus 135 is 45. Okay, so if I look at here, if I wanted to rotate about A 45 degrees, okay, would I end up the same spot? Obviously, I would not, because this is 135 degree. A 45 degree rotation, I'm going to be somewhere over here, not way over there. So just because 180 minus 135 is 45 doesn't mean that I can substitute that for the two different rotations, because there were two different centers of rotations. So here this is no, because we had two different centers of rotation. So my first rotation was about B, my sixth drummer. And then my second rotation was about A prime, my first drummer, after my first rotation. All right, so again, the big thing with rotations, we have to know positive and negative. So remember that positive angles are counterclockwise, negative angles simply mean clockwise. 90 degrees moves one quadrant, 180 moves two quadrants, 270 moves three quadrants, and 360 takes me right back to the fourth quadrant where we started. We need to memorize the rules for a 90 degree, 180 degree, and 270 degree rotation. And again, just remember that the negative angle will tell you that we are going clockwise instead of counterclockwise. Our homework will be the rotation worksheet over this.